We shall use ratio test in this question. And because you're going to use ratio test, you can start by writing what S sub n is. I've already started off a question. So S sub n is given by that. S sub n plus 1 will be given by this bit here. And then what I've done is basically to simplify this to end up with that, so that when I plug it into the ratio, the formula for ratio test, it will be easier for me to simplify it. So once you have S sub n and S sub n plus 1, plug them into the formula for ratio test. Okay. Now get the reciprocal of that. And then as you change that to multiplication sign, from division to multiplication, and then rearrange this guy so that you can simplify them easily. And you end up with this. Now what I'm going to do is I'm going to factorize out absolute value of a third into x minus 4, because these are constants. You can actually write this as a third absolute value of x minus 4. And then we get the limit as n approaches infinity of 2n over 2n plus 2. Now here you can use LHR, L'Hopital's rule. This will be equal to, it's easier to write below here, a third absolute value of x minus 4, and the limit of this will be equal to 1. So basically we'll end up with this as our answer. Now what we can do in this stage is basically to think about the conditions for convergence of the ratio test. So this should be less than 1 for convergence. All right. Maybe I can add some more details here just to avoid confusion. This will be equal to a third absolute value of x minus 4. All right. But this should be less than 1 for convergence. All right. For convergence. Because remember, trying to find the interval of convergence, which means you can multiply the right hand side by 3, so you'll end up with x minus 4 is less than 3. Now 3 here is actually the radius of convergence, but I'll just carry on working out my solution. So you'll have negative 3 x minus 4 to 3. Add 4 on both sides, you'll end up with 1. The values of x being between 1 and 7. Now remember, we have to check the endpoints. The endpoints. All right. But from here we have said that you know, that is actually the radius of convergence, which is 3. Or you can just, you know, find it out from the interval of convergence. Either way, it works. So at x is equals to 1, our series will be now if you simplify this, this can be written as negative 1 to power n multiplied by 3 to power n over 2n 3 to power n. And these guys will cancel. So what you end up with is an alternating series test, alternating series. So n is equals to 1 to infinity, negative 1 to power n over 2n. So this is an alternating series which converges by alternating series test. So this guy. All right. And we can carry on to investigate the other point. This was x is equals to 1. So at x is equal to 7, our series will be just plug 7 in place of x. Okay. So remember 7 minus 4 is 3. That's why I ended up with 3. This simplifies to, because these guys do cancel, this simplifies to this series. You can find whether this series converges or diverges by using the comparison limit test. So using the comparison limit test, and I'll use the harmonic series, compare this with the harmonic series. So limit as n approaches infinity of 1 over 2n over 1 over n. This is same as limit as n approaches infinity of n over 2n, which is basically equal to a half. Now, from the comparison limit test, the limit comparison test, when the limit of s sub n over b sub n is equals to c, where c is between 0 and infinity, then both series behave the same way. Now we know that a harmonic series diverges, which means that this series that we have here at x is equals to 7 also diverges. So you can say okay, so what does that mean? It means that one of our points is inclusive, another point is not inclusive. Hence, the interval of convergence will be from -1, including -1, to 7, excluding 7. Right? Okay. Next question. Find the values of x that will make this series to be convergent. So basically, we want to find the interval of convergence for this series. So we're going to use the ratio test. Okay, so you have those expressions. You're going to plug them into the ratio test, formula for ratio test. Have to be careful to use K, not N. So this will simplify to um, we can rearrange this, make it easier for us to simplify. Um, the first expression, first term will just be um, x minus 2 to power 1. And the other term we can just alternatively, I can just factorize out x minus 2. So absolute value of x minus 2. And then here I can write k plus 1 over k plus 2. Just use brackets. All this to power a half. And just use LHR. This will be equal to this will be equal to 1, whatever is inside the blue bracket. So our answer will just be absolute value of x minus 2. But for convergence, this should be less than 1 from the ratio test. Which means we'll end up with a -1. Add 2 on both sides, we'll end up with this inequality. Check the endpoints. So at x is equals to 1, our series will be this one. If you plug 1 in place of x, that will be -1 to power k over square root of k plus 1. Now, this is an alternating series which converges by alternating series test. So At x is equals to 3, we have this series. If you plug 3 in place of x, you'll have 3 minus 2, which is 1. So our series will be just 1 to power k over square root of k plus 1, which is the same as 1 over square root of k plus 1. Now, we don't know whether this series converges or diverges. One way, the easiest way actually to find this out is maybe this will be a shortcut, is you can rewrite this as instead of starting from k minus k is equals to 1, you can start from k is equals to 0. Now, when you subtract 0 here, so, if you reduce by 1 here, you add. So if you reduce by 1 here, you add. Well, that one really. Anyway, I'll just use the limit comparison test. Okay. So use the limit comparison test. So I'm going to compare this with a series that I know that diverges, and that will be 1 over square root of k, because by p series test, that series diverges. So anyway, take the limits of the two. So the limit of may create more space here. This can be written as so that can be written as square root of k over square root of k plus 1, which can be written as k over k plus 1, everything to power a half, which will just be equal to 1 by LHR, L'Hopital's rule. And then you can carry on and say that because this series, since the series that I picked just checking my solution. All right, this should be k is equals to 0. Not really 1. K is equals to 0. Anyway, just gonna carry on. So here, since this series here diverges by p series test, then by limit comparison test, this one here diverges as well. Okay, so we can make our conclusion and say that the interval of convergence, hence the interval of convergence, is between 1, for all values of x between 1 and 3, this series should be able to converge.